Good morning. Dr. Bindhu, Assistant Professor, Department of Science and Humanity, Emmanuel Arasar JJ College of Engineering, Nattalam. Today I will explain the eigenvalues and eigenvectors. Find the eigenvalues and eigenvectors of A. If A equal to matrix of 1, 3, 9, 1, 3, 4, 0, 0, 2. First we can find the eigenvalues. Then first we can write the characteristic equation determinant A minus lambda I equal to 0. Then we can write lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Next we can find the value of S1, S2, S3. Then S1 equal to sum of leading diagonal elements. Then given matrix, then diagonal elements is 1, 3, 2. Then 1 plus 3 plus 2. That is answer is 6. Then S2 is sum of minus of leading diagonal elements. Then choose the first diagonal element is 1. Then remove the row and column. Then write the remaining matrix elements determinant 3, 4, 0, 2 plus next choose the diagonal element is 3. Then this column and this row is remove. Then write other elements determinant 1, 9, 0, 2 plus next choose the diagonal element is 2. Then this row and column is removed. Write the remaining elements. Then determinant 1, 3, 1, 3. That is equal to then 3 into 2 6 minus 0 plus 1 into 2 2 minus 0 into 9 0 plus 1 into 3 3 minus 1 into 3 3. Then first value is 6 plus second value 2, then last value is 0. Then total answer is 8. Next we can find S3 value. Then S3 equal to determinant A. That is equal to determinant of some elements. Then next we can find this value. That is equal to then 1 into then remove the row and column. Then other element 3 into 2 6 minus 0 into 4 0. Then next minus 3. Then second column element minus 3 into then this row and this column is removed. Then other elements 1 into 2 2 minus 0 into 4 0 plus then other 9 into this column and row is removed. Next 1 into 0 0 minus 0 into 3 0. Then next then first value is 6 minus second is 3 2s are 6 plus last term is 0. Then answer is 0. Next then write the characteristic equation for A is then S1, S2, S3 values are given there. Then substitute this characteristic equation. Then lambda cube minus S1 value is 6 lambda square plus S2 value is 8 lambda. Then last S3 value is 0. Then that is equal to 0. This is a characteristic equation. Next we can find the value of lambda. Then this equation lambda is a common value. Then take the outside lambda into write the remaining value lambda square minus 6 lambda plus 8 equal to 0. That is lambda equal to 0. Then we can find the root value. Then value is multiply elements is 8, then adding element is minus 6, then minus 2 minus 4, then minus 2 minus 4 is a plus 8, then the minus 4 minus 2, then value is a minus 6, adding element is minus 6. Then we can write lambda minus 2 into lambda minus 4 equal to 0, then lambda equal to 2, then lambda equal to 4. These values are a eigen values. Then lambda value 0 to 4. These three values are eigenvalues of A matrix. Next we can find the eigenvectors. First we can solve the equation A minus lambda I into x equal to 0. Then write the A matrix value minus lambda into I. I is the identity matrix. Then diagonal element is 1. Remaining entries are 0. Into x value is x1, x2, x3. Then next line, then lambda is multiply the inside the matrix. Then this is, then next line is subtract the 2 matrix. Then 1 minus lambda 3, 3 minus 0 3, 9 minus 0 9. Then 1 minus 0 1, 3 minus lambda, then 4 minus 0 4, then 0 minus 0 0, then 0 minus 0 0, then 2 minus lambda into x1 x2 x3 equal to 0. Then equation A. Next, first find the eigenvector, then case 1, then first we can apply the lambda equal to 0 in equation A. Then lambda value is 0. Then equation A. Then value is 1, 3, 9, 1. Lambda value is 0, 3, 4. Then 0, 0. Then lambda value is 0. Then 2. Then x1, x2, x3 that is equal to 0. Then we can write the equations. Then first equation 1 into x1 plus 3 into x2 plus 9 into x3 equal to 0. Then write the next equation 1 into x1 plus 3x2 plus 4x3 equal to 0. The last one is 0 into x1 plus 0 into x2 plus 2x3 equal to 0. Then we can solve the equations 1 and 2. This equation solved by the rule of cross multiplication method. Then cross multiplication method. Then first row is write the coefficient of equation 1. Then first x1 coefficient 1. Then x2 coefficient 3, then x3 coefficient 9. Then repeat the one time 1, 3, 9. Then next write the second equation coefficient 1, 3, 4. Then 1, 3, 4. Next repeated the one more time 1, 3, 4. Then out the last, then first values and start value and end values. Then this remaining values given there. Then first, then we can find the x1 value is first two columns. Then second x2 is find there. Then the second and third column. Then x3 value is find there third and fourth column. Then x1 divided by, then the cross multiplying there. Then 3 into 4 12 minus 3 into 9 27 equal to, then x2 divided by, this is 9 into 1 9 minus 4 into 1 4 equal to x3 divided by 1 into 3 3 minus 1 into 3 3. Then 12 minus 27 minus 15 equal to, then 9 minus 4 is 5. 3 minus 3 is 0. Then minus 15, 5, 0. Then the multiplying, then minus 5. Then minus is cancelled. Then 5 divided by 15 is 3. Then minus is given there. Then 5 divided by 5 is 1. That is equal to x3 by 0. Then x1 value is 3. x2 value is 1. Then x3 value is 0. Then next write the eigenvector E lambda 1 equal to, then first column element 3 minus 1 0. This is a first eigenvector to lambda equal to 0. Next case 2, lambda equal to 2, then substitute, then equation A, we get this answer minus 1 3 9 1 1 4 0 0 0. Then x1 x2 x3 equal to 0. Then first write the equation, then first row into this columns, then multiply there minus 1 into x1 plus 3 into x2 plus 9 into x3 equal to 0. Then next 1 into x1 plus 1 into x2 plus 4 into x3 equal to 0. Then last row value is 0 x1 plus 0 x2 plus 0 x3 equal to 0. Then we can apply the same procedure for case 1. Then apply the cross solving the x1, x2, x3 value. Then apply the method is cross multiplication method. Then take the two equations, 4 and 5 equations. Then first we can write the first equation coefficient in 2 times and next write the second equation coefficient in 2 times. Then start and ending point is out there. Then remaining values, this is a x1 value, this is x2 and this is x3. Then x1 divided by this cross multiplying there, 3 into 4 12, 1 into 9 9, then minus 1 into 9 9 equal to x2 divided by 9 into 1 9 minus 4 into minus 1 minus 4, that is minus into minus plus, equal to x3 divided by minus 1 into 1 minus 1 into 3 3. Then x1 by 3, x2 by 13 equal to x3 by minus 14. This x1, x2, x3 values are find there. Then E lambda 2. Next eigenvector is 3, 13, minus 4. Then case 3, lambda equal to 4 from equation A. Then this matrix is given there. Then write the equations. Then same procedure for case 1 and case 2. Then first 3 equations are right there. Then solving 7 and 8 equations. Then apply the cross multiplication method. Then we can solve this line. Finally, the solution is x1 1, x2 1, x3 0. Then we can write the eigenvector E lambda 3 equal to 1 1 0. Thank you.